All right, good morning, guys, or good morning once again. I want to walk you through some problems that involve sharing a job or a task. You know, we talk about how it takes a certain amount of time for one person to do something and a different amount of time for another person to do it. Well, how long does it take if they work together? And these problems, I think, are probably the most counterintuitive. They're the weirdest problems at first glance. But once you give them a shot, you realize they're just not as bad as you think. And so I'm going to do my best to explain it. And so I'm going to walk you through one. You're going to try one. I'll walk you through that one and another one, and then you'll try another one. Okay. And so we're just going to kind of take a look at these. So here we have Coleman and Parker share a paper route because people still do that, right? It takes Coleman 70 minutes. Okay, that's important. It takes Coleman 70 minutes to deliver all the papers when he does it by himself. It takes Parker 80 minutes to deliver the papers all by himself. And so Coleman's just a little bit quicker than Parker. And so let's talk about how would we do this? How would we figure out if they're doing it together? Now, really, when I think about these, if I was just real quick glance, I'd go, well, just average the two. 70 plus 80 and divide by 2, I'd get 75. Well, that doesn't make any sense because that would literally mean it takes Coleman 5 minutes longer when Parker helps him. And that doesn't make any sense, okay? And you go, well, let's take 75 and cut it in half and 37 and a half. Well, where did that come from? I don't know. And that might be close to the answer, but that's still just, there's no math in that. We're still just taking educated guesses at best. So let's talk about how to do this for real, all right? We've got these numbers, and so I'm just going to go ahead and kind of list those as well. So we got 70 minutes is how long it takes Coleman to do it, all right? And 80 minutes is how long it takes Parker to do it. Okay. Now, what I want us to think about, and then we got one other thing. X number of minutes is how long it takes them to do it together. So those are our three things that we need to know. Now, this is kind of an odd question, but I want you to think about what happens if it takes Coleman. These numbers are kind of big, so I'm going to use smaller numbers for just a second in an example. Well, let's say it took Coleman 10 minutes to do the whole thing. Think about that. It took him 10 minutes. Well, how much does he get done in 1 minute? Well, if it takes him 10 minutes to do the whole thing, how much does he do in 1 minute? Well, he does 1/10 of it in 1 minute. And it's important to see that relationship. And you go, well, if it took him 15 minutes, how much does he get done in 1 minute? Well, it'd take him 1/15. And so we see there's this reciprocal relationship. So the same thing applies here. So if I say 1/70th or 1/70, that's how much Coleman gets done in 1 minute. That's how much of the job he completes in 1 minute. Okay, so Coleman completes in a minute. Okay? And then clearly, then for Parker, it would be 1/80th of the job is how much he gets done. Parker completes in a minute. Okay? And we have no idea how long it takes them to do it together, but the same reciprocal relationship applies. And so 1/x, no matter what that is, let's say it takes them 5 minutes to do it together. Well, then how much do they do in 1 minute? 1/5 of it. And so all of that makes sense when we're talking about numbers, but it doesn't make a ton of sense when we're talking about bigger numbers or even worse, talking about variables. But 1/x would be how much is completed by both completed in 1 minute. Okay? And there you go. That's our relationship. That's our equation, really. What we've got to do here is we go, okay, so I know that how much Coleman does in a minute, if I combine that with how much Parker does in a minute, I will get how much they together do in a minute. And so I'm realizing that this much done in a minute, plus this much done in a minute will give me how much they both can do in a minute. And I just have to solve this. So I think common denominator here is 560. And so I have to multiply the top and bottom of this one by 8. Multiply the top and bottom of that one by 7. And so this one becomes 8 over 560 plus 7 over 560 equals 1 over x. I combine those and I get 15 over 560 equals 1 over x. Okay? And with that, I say, well, cross multiply and solve. And so you would get 560 is equal to 15x. You could divide both sides by 15. And unfortunately, 15 does not go into 560 evenly. It goes into 555 evenly. It goes into 570 evenly, but not 560. And so x is equal to, well, how many times does it go in? Well, it goes in, let's see here, about 47 times. 47 and a third. That's how much? 47 and a third. Okay, so what is this right here? This is the number of minutes it takes for them to complete the job if both of them are doing it. Okay, and so that you always got to answer the question. So it takes them both 47 and 1/3 minutes to work together. That's not bad. Good. Okay, yay. And it's that simple. Wait a minute. Is my math wrong? No, I think that's right. Okay. Anyway, if my math is wrong, I apologize. I'm not using a calculator right now. So if you divide 560 divided by 15 and you get a different answer, you're like, man, Watkins is crazy. Oh, I am crazy. It's not 47. It's 37 and a third. What's wrong with me? I'm so sorry. You guys are probably making fun of me right now. That's okay. I don't care. All right. It's 37 and a third. Okay. How much do they complete? Or how long does it take them? It takes them 37 and a third minutes. Fantastic. Sorry. I just double checked that. Okay. Moving on. So now what I want you to do is I want you to try it. Ready? The Three-Way just started selling an extra large pizza. This pizza is 36 inches across. That's 3 feet. Tessa, all by herself, can eat that entire pizza in 45 minutes. But that's nothing compared to Michaela, who can all by herself eat that pizza in 30 minutes. So how long would it take for both girls to eat the pizza if they worked together? What a cool dream and a goal for them to work together on eating that pizza. Okay, so what I want you to do is I want you to try to set this up and solve it the same way. You can pause the video right here to kind of give you a chance to work on it, and then we'll come back in just a second and work through it. All right, and we're back. Well, hopefully you figured this out and you realize this is not hard, especially once I showed you that other one and you saw that situation there. Okay, so we look at this and we go the same way. Let's set it all up. We know. Let's talk numbers here. We know 45 minutes. What's that? That's how long it takes for Tessa, hungry Tessa, to eat the pizza. Okay, 30 minutes? Yep, hungry Michaela. That's how long it takes for Michaela to eat the pizza. All right. And then X, number of minutes, is how long it takes for them eating it together. Now, I don't mean splitting it. Like, here, you take half and I take half, because that would be a different math problem. I mean, they are both literally just eating it as fast as they can, and once it's gone, it's gone. They don't care if they get even portions or anything like that. Okay, so hopefully you set up this much, and then you realize it's that reciprocal relationship. You go, what happens in 1 minute? Well, Tessa would eat 1/45th of it. And what happens in 1 minute for Michaela? Well, she would eat 1/30th of it. Okay, and so therefore I know that in 1 minute, Tessa eats 1/45th of it. In that same 1 minute, Michaela eats 1/30th of it. And so the result is 1 over X. That's, we know that kind of represents how much time it takes for them to eat it together. And so we know that that's going to be the setup. So at this point, we go, well, what's the common denominator of 30 and 45? That'd be 90. So this is 2 over 90 plus 3 over 90 equals 1 over X. And we combine that, we get 5 over 90 equals 1 over X, cross multiply. And we get that 5X is equal to 90, divide, and sure enough, X is 18. So what in the world does that mean? That means it only takes them 18 minutes. Good job, girls. 18 minutes to eat it together. Way to go. Hopefully you all got 18 minutes. You saw that this was a pretty straightforward, pretty simple problem. Okay, well, now let's put a little bit of a twist. Not much of a twist, just a little bit of a twist. Okay, so here's the little twist. For example, numero dos. Okay, we're going to say that Jacob and Jacob, the two of them together, can mow the lawn together in 40 minutes. Now, Jacob, he works twice as fast as Jacob. So how long does it take each Jacob to mow the lawn alone? Now, I'm not going to tell you which Jacob is fast and which Jacob is slow, but we're just going to call him fast Jacob, slow Jacob, okay? And so let's take a look at this. We know that together they can rock this thing out in 40 minutes. And the other important piece of information is that one of the Jacobs works twice as fast as the other one. Okay, and so let's start coming up with some numbers for this. So we go, okay, let's say that X is, well, let's say that X is the time it takes for fast Jacob to mow. Okay, well, if he can do it in X number of minutes and he moves twice as fast. Okay, think about this. Well, let's say X is 10 for a second. And then we're saying he can mow it in 10 minutes. Well, how fast does slow Jacob do it? Well, slow Jacob would do it in 20 minutes. It's going to be, if this is the fast Jacob and he works twice as fast, then he's going to do it in half the time. The other Jacob is going to do it in double the time. So that leads us to 2X is the time it takes for slow Jacob. I don't know which one that is, to mow. All right? But together, they get the job done in 40 minutes. So, same thing. We say, all right, that would mean that 40 minutes is the time together. That makes sense. Okay? Well, same reciprocal relationship. We know that 1 over X plus 1 over 2X must equal 1 over 40. Now remember, you can't combine denominators. Sometimes when we understood that up here, but down here, the fact that we have x's, man, it makes people throw all the rules out the windows. And they're like, oh, x and 2x, that must make 3x. You can't do that, okay? What you do is you got to find a common denominator, just like always. So you take this one, you multiply the top and bottom by 2. So you get 2 over 2x plus 1 over 2x equals 1 over 40. That makes sense. We have common denominators. So that would be 3 over 2x is equal to 1 over 40. Cross multiply, and we get that 2x is equal to 120. Divide both sides by 2, and sure enough, x is 60. Okay, so what does that mean? Well, let's go back up. X is the time it takes for fast Jacob to mow. So when the fast Jacob's mowing, so Jacob, all by himself, can mow in 60 minutes, while it takes Jacob 120 minutes. Now, where did I get 120? Well, this guy, remember we said that the X was fast Jacob, so he's doing it quicker. The other one works half as fast, so it's going to take him twice as long. So Jacob all by himself can mow it in 60 minutes, while it takes Jacob 120 minutes. Okay, now you try it. You do the same type of problem, but this time it'll be a little bit more fun because it involves me and eating ice cream. Okay, so here's the you try it. You ready? Coach Watkins and William can finish a 3-gallon bucket of ice cream. If you've ever been to an ice cream place where they got to scoop it out, that's how big those containers are. Those real big containers they reach down in. Those are 3 gallons. So Coach Watkins and William can finish a 3-gallon bucket of ice cream in 60 minutes. Now, not to brag, but I can eat ice cream 5 times as fast as William. Hey, I have a gift. How long would it take each of them if they were going to eat it alone? Okay, real similar situation. See if you can set it up, give it a try, and we'll see what it takes. All right, we'll pause the video right here, let everybody give it a try, and then we'll work it out together. So see you in a minute. Okay, here we are. We are back. Let's give it a try. Okay, so hopefully you kind of thought through this and you came up with some variables. I'm going to use the variable x. Now, which one is x going to be? I'm going to say that x, it kind of, to me, it makes sense to make x the faster person, because otherwise I have to use a fraction. Think about it. Up here, if I used x as the slow Jacob, then the fast Jacob would have been 1/2 x. And so just to keep it fraction free, I'm going to make x is going to be, x is the time it takes for Watkins to eat it. Okay? And now I go 5 times faster than William. Okay, so if it takes me, an hour, and I go 5 times faster, and it takes William 5 hours. Okay, and so that's how we got to think about this. So therefore, William takes him 5x. Sorry, man. You're the kind of guy who likes to slowly enjoy your ice cream. Man, I just inhale it. It's like breathing, okay? So 5x is the time it takes William. I like that. I wrote x is the time it takes for Watkins. Oh, yeah, I guess that makes sense. It takes for William to do it. It just seemed weird. I think it's bad grammar. All right, and then we know total together, there we are at 60 minutes, okay? So 60 minutes is when we share the job. Share the job. Okay, same reciprocal relationship. 1 over x plus 1 over 5x is equal to 1 over 60. Remember, don't do anything silly or foolish with these fractions. For some reason, we know we got to do common denominators, but when we have variables on the denominator, we start to make mistakes. But so I look at this and say, well, I'm going to multiply the top and bottom of this one by 5, and that's going to give me 5 over 5x plus 1 over 5x equals 1 over 60. Well, 5 plus 1, it gives me 6. So I have 6 over 5x equals 1 over 60. Cross multiply. If I cross multiply from there, I'm going to get 5x is equal to 360. Is that right? I think so. And so therefore, divide that by 5, and x is equal to 72. 72 what? 72 minutes. So what does that mean? That means if I am all by myself, I can eat that 3-gallon bucket of ice cream in 72 minutes. But if William helps me, we can rock that bad boy out in 60. So he helps me a little bit, but, I'm inhaling this stuff, all right? And so I asked how long would it take each of them to eat it alone. So this is just me. This is just my time. And so it takes me, okay, so let's see, let's try to use a little bit of grammar. It takes Watkins 72 minutes to eat 3 gallons all by himself. Okay, so what does that mean about William? Well, if it takes him 5 times as long, here's our answer. Boom. Okay, wow. It takes, I'm not sure if you realize how much time that is, but 360, divide that by 60, that is 6 hours. Okay, way to go, William. He's like an endurance ice cream eater. Man, that's like an Olympic event. It takes William 360 minutes, which is also 6 hours, to eat 3 gallons of ice cream alone. Way to go, William. I'm impressed. Okay, so now we've talked about this. Hopefully, you're pretty good at the mixture problems. You're pretty good at, the sharing a job problems. And hopefully, you guys are ready to go and you guys can get started on the homework. And I will see you tomorrow. All right, you guys have a great day. Thank you very much.